So let's do some examples with arrays. If you want to follow along, that'd be great. So we can build something together. Also get you, some hands-on how you can, start writing arrays, creating arrays, and how you can populate arrays, and also do some other data manipulation with arrays. So let's create a new project in the Visual Studio. Make sure again it's in the Windows Forms application. And then I will call this project, is it chapter 7? Yeah. So chapter 7 of arrays. Okay, so let's design this form just a little bit. Let me turn on my toolbox, the properties, and I don't need my solution yet, so this is all good. Mine's a little bit dark on my screen. All right, so we're just going to have a list box here. So I'm going to go to the common, and I will add a list box to this form, and then probably not that big, but okay, I'll change the name of that list box to LST. Just again use result for now. I'll change the font to something a little bit bigger, maybe 20, my usual number, and we'll add some data here. Okay, so I'm gonna just load the my base.load handler, and so you do that by just double clicking on the form, right? You double click on it, and it should give you this my base.load, and this is for like initialization your list. Okay, so we did that last time, but let's do it again. So I'm going to populate this list box with some data. I'm just to show you that so you remember to do that. So the list box here there's no data here yet. So if you want to populate that list box with some numbers, with 10 numbers, for example. There are lots of ways to do it, right? So with the list box we learned before is just lst.list result.items, okay, .add, right? And then we can put like on 1 in there, right? And you can do that 10 times to add 10 numbers. So so for example, you could do like you can copy that 10 times. There's a lot of work, right? Put 1, assuming that it's just 2 and 3 and 4 and so on. You can do that 10 times, which is a lot of work. It would work, but just a lot of typing to do. So usually, if the numbers are in that order, then or any random number, we can also use a random generator to generate the random number. But if you just add 1, 2, 3, 4, 5, 6, 7, 8, 10, then the easiest way is just to use a loop. Right, so we did that before. So instead of doing this, I could use a loop to generate the list for me. So we could use like since we know we want to add only 10 numbers, so we'll use a for loop for next, right? For I, just the counter I as the index, as integer from the 0 position to 9. Okay, we only want to add 10 items, so that will give you 9 items. If you put 10, that's inclusive. This number is inclusive. Then it's going to add 11 items. So then we're going to end that here. So 4 and then next end. Then here, if you don't want to include 0, then you would say I plus 1. So it would add 1, 2, 3, 4, 5 to 10, not including 0. And that's how you will populate this list, right? and let me just go back to my design mode, and I want to center my form. So again, just in the stop position, make that center screen so it's always in the center. Okay, so when you run it, you'll see that it's populated 1 to 10. Okay, so and this box is a special type of collection. As you can see, I didn't have to specify the size of this list, right? I can design it in any way I want. I can change the size to anything. If I want to add to 100, that automatically adds to the list, and the list, you know, expands or shrinks automatically. And also by doing this, after I add to the list with the 10 items, I could also then go back and remove one of those lists, and then also that should still be okay. Okay. So again, this is the index, also called the subscript of the list box, which is the same as the index that we use for a string. It's the same index for an array. Okay, so when it says sub or the index, it's always referred to the position of that list, of the position of the character in a string or the element in the array. Okay, in this case, it would be the item in that list. Notice I use the word item instead of a element, but they are pretty much the same thing. So to declare an array, we would just declare just like you would with any variable name, right? If you want to declare some numbers, then you could just say dim numbers, and here you put the paren here. If you want to specify the upper bound, which is the maximum index, then you put that here. So if you want to put like 10 items, then this has to be 9. Okay, that's the upper bound. This is the same as this, going from 0 to 9. And then you give the data type as, for example, integer. And there's my array declaration. Okay, you will declare an array of that size, and you are not setting any values to the array. So since it's integer, that means that it automatically populates the array with all zeros, right? These are the default values. So that means if I were to, let's just say, let me comment this out. See if that is true. Okay, so I'm gonna comment that out, and if I want to add these numbers to the list, well, maybe we're just gonna copy this, put it down here. Okay, and then I'll uncomment this. Instead of I'll put, you know, the numbers of I. Okay, right? It's going to print the numbers from 0 through 9 here to the list, to the list box. And since I did not initialize this to any default values yet, so as soon as I declare that, I would assume that this will be all zeros, and we'll see if that is correct. Okay, so let's run this. And you can see this is all 0. So that's the default value if you don't assign any values to the array or any variable. In that case, it's an integer type. Okay. If it's a double, it would still be 0, or it would be 0.0 if you want to force a decimal number. What if it's a string? What if it's a string type? Okay, so you can see that I changed this to string type. Now, really the name is numbers. It's kind of misleading, but it doesn't matter, right? All that matters is the data type. Okay, so this would be a really bad way of naming your variable name, numbers, but then you put it as a string. Okay, so what that means that it's just, you know, you can only store strings inside the numbers array. Again, doesn't make sense here, but just want to show the default values of a string type. So let's see what that looks like. So as you can see, there's nothing, right? It's a blank space. So the default values for string is just empty string. If you put a different, like Boolean type, for example, So Boolean, the default will be false, right? All false. So as you can see, as you declare variable types of any of these types, then the default values will be assigned to the array automatically. Okay? So again, you change it back to integer. And if you want to change the values inside this element, then you need to access the position and then assign that to with a different number. So I could assign the arrays here by using the same loop here, right? So you could do, like, for example, you could do that and then just say number of I, okay, equals maybe I plus 1, right? That will store 1 through 10 inside the numbers array. And then now I do another loop to print the numbers from 0 to 9 to the list box. Then now I get a whole list from 0 through 10. Right? So if you run this, you see that it has a number from 1 through 10. But if you look at this code, it's redundant. So you can refine this code to make it better. How would you fix this code here to make it not too redundant? So you could just basically move this, right, and put it down here, right? And you don't need this part here. So you assign the values to the nums, and then you just basically reprint that back to the list box. So because you do something very similar from 0 to 9, you repeat that twice, and so this way you don't have to do it 2 times, and just do 1 time. Okay, just to show that it works. If I put plus 2 here, you see that number is now from 2 to 11 instead of 1 to 10. Okay, so this is one way you initialize arrays. By assuming that it's some really simple numbers, then you could do it this way, right? Much easier. If you put like 999, then still very easy to do. You just change the number, and the number of codes still is unchanged. Okay, it's very powerful because you can store all these data inside the numbers array. And so inside the numbers array really is, if you think of a container, so if numbers, it will look something like this, right? The first position, the second position, third position, and all the way to the nth position. So here would be like a 1, and then a 2 here, and then a 3, and then all the way to, and be like 1,000. Okay, so so the array will look like that. To access this position, then this will be at the 0th position. This is the first position, second, and then all the way to the 999th position. This is the index, right? These are your index, or the subscript. The 1,000, if you count at this, this will give you the total count, the size of the array. It's 1,000 element. If you were to count all the way from 0 to 199, you get 1,000. Yeah.
When you create these arrays, do they sit in RAM?
Yes.
They don't write to the hard drive?
No.
Sit in the RAM?
Yes, only in RAM. Yes. If you want to write it to the storage, that'll be out to a text file or a database. But yeah, it's all in RAM. So if I just to run this now, you see that the list box is there, and it goes all the way to there it is, 1,000, right? Very simple, very quick, very fast to write your code, to do any testing, and so on. So now we have 1,000 numbers in the array, and you can go more if you want. It's gonna reach the maximum of the index of the type here, which is the integer type. That means that it's a certain size that you can only go up to. So there's a limit, of course. But So that's how you would initialize or populate your array. Okay, that many size. If you want to, let's just say, so you can do that, or you could do the second method is to dim numbers, leave that blank, okay, as integer, and you can assign the numbers or the values right away by putting those into a bracket here, curly brace, and then you would put the numbers in there. So again, if you do this way, you cannot specify the upper bound in here. You can't put 4 or something in here, right? It's gonna put an error, say you cannot have this and that because they will contradict. What if I just want to put 2 here and I specify 4? So you have a conflict here. Okay, so either do it this way without initialization here at all, or you do it this way, and if you want the initialize at in a single line this way, then you don't put the number here. And this number is determined by the number of elements you add in the curly braces here. So in this case, I have 2 elements. Okay, I know there are 2 because I can see it, right? And the example we saw in the slide was that you read this from a text file and you don't know how many elements in a text file. So because it doesn't specify here, how do you find that out, right? So if I put like 3 and 4 of them, then if I put that in the if I take this out, if I want to add that to the list, I wouldn't use 999. It would be from 0 to 3, right? Because this is the 0th position, 0, 1, 2, and 3 position. So really this will be 0, 2, 3. And so now if I run this, it should print from 1, 2, 3, 4, because I have only upper bound of 3. But if you put 4 here, because you thought that the 4 is the maximum, then you will have an error, and it would say, well actually, this is not because, why won't this be an error? So 1, 2, 3. Okay, this is a little bit strange here. It should cause an error because 4 is out of bounds here. Okay, I have to figure out why, but usually this should not work because num of 4 you don't have it here. But let's just say if this number changes all the time, instead of you go here and manually modify this maximum upper bound, then what you want to do is you want to find the total length count of this or the upper bound of this, and then set that to a variable name. So you could do something like dim, maybe like max index or something, right? Had to be integer type. You can get that max index from the numbers array. You can get the count. Okay. Notice I don't put the paren here. Okay. You can't do that because this is, although it looks very similar to a function, right? If you remember, you call it a function or a subroutine, put a paren, and you put that here. If you do it this way, then it thinks that this is actually a function or a subroutine. Okay, so you have to take out the paren and just use the name and then the count, and that will give the number of count, which is 4, and then just make sure you minus 1 to get the position of 3. Different 0, 1, 2, and 3 here. And then so now you can say from 0 to max. And I can change this any size, and now I don't have to worry about the maximum there. If I now put like 5, 6, 7, and it will be max minus 1. So in this case, it will print to 7 without any problem. Okay, so max count is the total of the array minus 1. That's one way to find out. Another method is you could do, so this could be like instead of max count, let me copy this. Oops. This is one way. Another way is to use the get upper bound, okay, of sub-zero. This get upper bound is a built-in function that will give you the exact max number of this array, the max index. So in this case, we have 7 of them, but the index will be of 6. Okay, so this will return 6. And again, the keyword is get upper bound. It will grab the number usually inside here, right? If it's 999, then the max upper bound, the get upper bound will return 999, whereas the num count will be the actual elements, total elements in that array, and then to get the index, you have to do -1. Okay, so you use either method here is fine, and you have to put a 0 in here. You cannot just say like that. Okay, you have to put a 0 in there, and we'll revisit this again next week. What the 0 means is that first dimension of the array. Okay, so right now we're dealing with a single dimension. So this is a one-dimensional array. So the one-dimensional is the first dimension, which is the upper bound of sub-0. Right, again, it's 0-based. So the first dimension gives you the max upper bound. In this case, it would be the 0th dimension. But it is just the first dimension, and it will give you the actual number. Next week, when we deal with 2 dimensions, then you get the upper bound of 0 and also the upper bound of 1, and you get the second dimension. And if you have a 3 dimension, you put 2 and 3 and so on. Okay, so for now, it's just the upper bound of 0. Either way, you want to choose either way, it's completely fine. So again, if you run this now, you should get the same result from 1 to 7 without a problem. Any questions on how this works? The array, how you declare them, how do you assign values to the arrays? Very simple, very easy. Again, the data type is important. Okay, you cannot mix in here. Suddenly you put like A in here. Okay. Notice it doesn't give you any error. Okay, it does now. It doesn't print anymore. Okay, because I didn't put the strict on. If I put the strict on, again, depending on which version you use, put like the strict, the option strict mode to be on. You see that it will tell you this is a wrong data type. If you don't have it on, if it's off, I think default is off. That's why it didn't give you the error here. So it also means that I don't have to specify the data type. I could just do this, and Visual Basic is smart enough to know what data type it is, right? So in this case, it will treat this as an object type. Okay, that's what it allows you to have these numbers and strings together here. So this would be like, as I'm saying, of object. And we don't do object yet until chapter 11, but so usually you put integer, and if you give an error, that's good, and this should be always set to on. So again, just to kind of force you to make sure your data are consistent with other data types as well. So in this case, you see that it now says you cannot put a character in here because of the integer data type. If I put 2.5, also gave me an error because it's a number. Why would that be an error? Yeah, it's a double decimal number, right? And the only reason is because, what if I do this? Now, why does it accept both types? If I switch it, it doesn't accept. Okay, the reason why it accepts a double, because again, it depends on memory size. Okay, so integer, let's just say integer, for example, if you wanted to kind of do that, integer would have like let's just say you have this many space for integer, but for a double, right, you have this many space. Okay, you can store that many values. So as you can see, an integer can fit inside a double here, no problem. But you cannot put a double inside an integer, right? It's too small. So that's why if you do it integer this way, you have an error because this is a double. You cannot fit this inside this tiny space. It's all about memory size, okay? And in terms of numbers. Same thing if I put in here, if I put double, okay? And if I force it to be a decimal, yeah, well, double decimal should be fine. Okay, so there's a reason why it didn't let me put in there. So, so declaration of the array is the variable name followed by the paren, and if you know the size, you put that in here. If you don't, you want that. If you want this size to be dynamically generated, then you would do it this way, or you read it from a text file, you read it from another source, or you read it from a database. Okay, and then the upper bound will be automatically generated or tracked for you. And if you don't know what it is, you can get it by bless you, by issuing the get upper bound of the dimension, which is 0, or you can do the number dot count -1, give you the upper bound as well. Okay. So I mean so here we start from 0 to max, right? You can also do like you can also put that here. If you don't put that -1 here, just make sure you put a -1 here. Okay, so depending on where you put it, you have to put it somewhere. Otherwise, you get to the issue of the out of bound errors. Okay, because this only gives you the count, which is 7, but the max index is only up to 6, so you have to subtract that from here. I mean, there are many ways to do this. Okay, let's see what else. And if you want to get the right, so the built-in some of those built-in functions are available for us to use. If I change these numbers here to, let's just say 10, 21 and 13 and 45 and 35, 26 and just 7, right? And if you want to get the maximum number out of this list, you can see that it should be 45. Okay. So to get that maximum, you could just output that to the items list, add the numbers dot max, right? That returns the maximum number, which is 45 in this case. You could say here, max number is max dot numbers dot max. You could also put get the minimum number, which is the smallest number. These are built-in functions, really useful. And I'll just put one here just to get the line drawn, so we know that from here it's a separate calculation. So the maximum, the minimum, you can also get the average. So average, so really easy, they're already built in for you. And of course you can get the first and last, so that first, right, and last, and several ways to get there. This is the same thing as saying numbers of what? The first will be number of 0, right? That's the first number, and then the last number is same thing as saying numbers of, in this case it would be max -1, right? because I didn't put the -1 here. So the max -1 will give you the last element. Right? Or you could say like numbers. If you, I mean, be a little more confusing, we can say numbers of numbers dot count -1. Right? Same thing. Or you can say get upper bound of 0. That also give you the maximum. So yeah, lots of ways how you can get that that max number, the last number. So since we know that is the max -1, that's one way to get there. Or you should dot less. Okay, so if I run it now, it should give me those results here. So again, the max is 45, the minimum is 7, the first is 10, last is also 7. First 10, last 7. The average is you add them all up, you get that average. So basically you add them all and you divide it by 7, which is the max count. So very quick, easy way to get these data for whatever purpose you want to use. So if you would like store some student grades and you want to get the average of those grades, put to an array, do the grades dot average, give you the average grades of all the students. The highest score and the grade, your classroom just dot max, the lowest score. Okay, get the middle number, right? You can do all sorts of stuff. Get the first, the last. You can even sort it. So notice this list is not sorted. So now we can sort that list. And if you were to like sort it, it will be sorted. So for example, this is not sorted. If I go and then after that, right in here, if I say array sort, and if I put the numbers in here, okay, it's now sorted in ascending order. Okay, so it will sort the numbers inside the array from 7 all the way to 45. Again, this is something that you will have to learn next week also. But there's some other functions that are already available for you to use. You can sort the array this way. So let's see if that is sorted. So you can see it's sorted from 7 to 45. Okay, automatically sorted for you. Which then kind of give you, okay, so that means the maximum number is always the last one. The minimum number is the first one, right? So you can use that as well if you don't have the max and the min function. And how do you do that with the array? Then you just sort it first. Okay. And then, well, what if you want to sort the lowest to the highest, or I mean the highest to the lowest, the other direction? Okay, you cannot just say sort numbers and then you can't choose ascending or descending. And database you can, but in this you can't. So when you do that, you can say, hey, I sorted first from 1 to biggest, smaller to biggest, and then there's another function called reverse. Now I reversed the array. So now if you go from, so you sort it first, right, from smallest to largest, and then you reverse it, now it's from largest to smallest. And then if I run it now, you see that it's sorted in the opposite direction, from largest to smallest. Okay, and this applies to both numbers and text as well, or strings. But then it doesn't matter if it's sorted or not. You still get the maximum, still be the same. The minimum will still be the same. Average is the same. The only difference is the last and first are different now because you sort the array, and so the positions are now swapped. The actual values in those positions. Then if you do another reverse call, then you're just basically going back to sort it from smaller to largest again. So you can do you can go back and forth this way. Okay, so you can use that for some type of manipulation. Now, remember that when we do, like, for example, if I give you, we said max is that count. If I have another variable in here, if I say dim just num as integer, if I assign this number to max, right? So both max and num, they have the same value. So I could say here just num, right? It would still be fine, right? Because I'm basically give a copy of maximum to number, right? But if I, after this, if I say now number is now, 5, what happens to max? Does max change 2 or no? Is max still, in this case, 6, or is it max now is 5? What do you think? Okay. So these are called primitive data types or simple data types. That means that they have their own memory location. As soon as you create a variable called max and numbers, of course, and num here, they have their own memory locations. And even though I assign the value of max, which is 6 in this case, to num, they have the same value. If I change num's value here to 5, it's not going to affect max, okay? Because the max is still whatever this number is. So it has no effect of max at all. It would still be 6, okay? So this is a simple data type. And if I do, so in this case, if I say num is equal to max, which is 6, right? And then now I assign another statement, say num is now 5, okay? What happens behind the scene, which you don't see, is that you actually, when you do this, it actually removes this from memory, and it recreates another memory location, and has now assigned a new number, new value. Okay, it does not keep the same location. It removes that from memory. It generates another num, and then it assigns a new value. So the whole process gets started all over again. Except you declare that the variable name, the placeholder is fine, but location is no longer the same, and it assigns a new value behind the scene. Okay. So this is true for simple data type. They are completely independent of each other. Okay, you cannot use one to manipulate the others because it's a non-reference data type. Okay, so you remember that we talked about how you pass data to a function or subroutine using the keyword by reference, by ref. You're passing the memory address to that variable name. So this is right. This is true, right? For in this case, so if I were to, let's say that if I remove these for now, comment this out. If I type in here max, if I put max here, and also if I type in here the num, you'll see that num is different. We'll put max back here. So max was 7. In this case, will be 7. We added another one, so 7. But num is 5, and then if I were to change that to 5, let's say this is 7, so it's 7. And if I type this again down here, right, you see that has no effect on max, right? Max 7. I rename, I assign the 7 to num. I change num to 5, and max is still 7. Okay, so it does not affect the actual value inside of max, because they're separate separate variable names, separate memory address. You just basically get a copy of the number, the value. Okay, so that is the idea of behind simple data type. Now, arrays are what's called reference data type. By default, it's automatically reference data type. So what that means is that if I were to create another variable name, let's just say right in here, I do like them new nums or new numbers, and I give it, let's just say, I know 7, right? Or if I don't know what that is, I can, maybe we put it down here. Let's put it down here, right here. I can get the maximum here, so I know the data size as integer, right? So this equals the number of the max index in here, whatever this max is, right? So if I change something here, then of course it updates that one, and it also updates my here. So if I have 8, then this will be a max of whatever, 8 or 7, it doesn't matter, of that many integer. So if I were to say, if I do this, if I put new number, if I do the same thing as I did down here, right? It's equal to numbers. Okay, so I'm just basically assigned all of these here to the new number arrays, and it has to be array in order to do this to work, right? I can't put like a max like that, okay? Because it's different. This is a simple data type. You go into an array, it doesn't work. Okay, so the same array had to be the same data type. If I put this as string, it won't work either, because this is integer, this is going to a string. Okay, it doesn't work. So so the idea is just I want to copy this array called numbers to a new array called new numbers. The same type, get the exactly same numbers in here. Okay, and of course, if I want to, instead of using the max numbers, we're going to put like in here the new numbers, right? New numbers instead, I will get the same result. I should show the same numbers here. So if I were to run this now, so it looks just the same, right? It's 10 all the way to 2, just like the list here. 10 all the way to 2. Okay, and again, I'm calling not the numbers, but I'm using the new numbers down here. Okay, and so I'm going to modify this a little bit. I'm going to go to the form here, and I will move that over here, make a copy of this, put it on the side, and we'll give it a new name for this one here. This will be the list box LST, maybe result 2. Let's give result 2. Result 2. And the reason I do this is because I want to show you that arrays are reference type. Okay, so back in the code. Now, so I'm going to add another line here. And I'll change this back to new numbers. So the result goes with new numbers. Result 2 goes, with numbers. And result 2, the new numbers. Okay, we can comment all these out for now. We just want to see what those two lists are. Okay, so I put the numbers to the list on the left. New numbers, which is if you look at this, is like a copy of the array to the result on the right. Okay, save this, run, and they should be identical, right? And this is because I put that here. I could just take that out. Okay, stop that. Okay, so they're same, exactly same numbers, same copies, right? Okay, so now I do the same thing as I did here. Okay, instead of primitive numbers, I want to say now my new numbers. I'm going to have, let's just say, new numbers. The first number, which is whatever that is 10. I want to change that to maybe 100. Okay, what do you think is going to happen? Okay, so I'm going to run this. So what happens is that it actually modifies the numbers as well. Right? I did not make any changes to numbers array. I just if you look at the code, so that changes as well as the other one. So I created my numbers, give those values. I create a new numbers array of the same size, and then assign that numbers to these new numbers. And down here, I'm changing the 0 position of the first number to 100 instead of 10 using this new numbers array. I did not modify the numbers at all. But my result shows that it actually affects the numbers as well. Okay? And if I were to also, let's say, after that, I want to change numbers, the last one, which is, I guess, 7, or I'll just put like the second number, to be, 300. Okay, so I'm going to change this to 300 instead of 21. Again, I'm just modifying numbers. So if I save and run this, again, you see the effects both places. Okay, so you got to be really careful with arrays. You cannot just assign one to the other and assume that if you change one of the numbers, the new numbers, it doesn't affect the original ones. It does, and it will. Okay, so if you happen to say, you know what, I don't like this list, I'm going to replace it with new numbers, everything, you also delete all your original numbers as well. Okay, so that's what arrays reference data type. What this means is that when you do this, you're actually not assigning the numbers, the values to the array. You're actually, in this case, assigning the memory address of numbers to the new numbers. So they're pointing to the same place. So that's why I modify numbers or I modify new numbers. I'm changing the actual number inside the memory address. So same thing, just saying, hey, here's my credit card. I give it to you. Use it. If you use it, it can also affect me because we share the same account, right? Same thing. So be really careful with arrays when you do this. The primitive type, no problem. It doesn't affect any of those, the original numbers, but arrays does. So if you want to make a copy of this number to a new array, you cannot just do this. So how do you copy all this to a new array? I mean, there's a built-in function called array copy. So that's kind of cheating, but they do have that as well. But to copy this, you can use a loop to do it, right? You have to use a loop to do this. So you're basically moving every element to the new number. Okay, so you want to copy it, you would do it this way. I'm going to comment that out, and I'll put it right in here, or maybe like right above here. Above here. So you want to say, for example, you can do for each, or you can do I. Use the other one. I as integer from 0 to max minus 1. Okay, is from 0 to max minus 1. Then you want to say new numbers of I. Every ith place is going to be assigned with the values from the numbers of I. This is how you copy arrays. So this way, now new numbers is a array element, a variable that has a different memory address, but it has the same copy of the numbers. So now if I make changes to the numbers, or the numbers, new numbers, it has no effect with the other array. Okay, so in this case, so initially if I don't do this yet, right, I made a copy of the new numbers to the new numbers. If I were to don't modify anything yet, you run this, you should get the same copy, exactly like before. Okay, because the same copy of numbers. Now if I modify the first number of the here to 100 instead of 10, and you will see that it should not affect the original array. Okay, it doesn't affect that because it's a completely different memory address. You just basically get a copy of the number. Same thing here. If I modify the numbers with the second element to be 300, it should not affect the second element or third element here in the second array. Okay, so that's how you make copies of an array of elements, and now you can play with the new numbers, modify the data, do whatever you want with it without affecting the original array. And if you don't, if you just say, hey, you know what, I don't like these numbers anymore, I want to restore the original number, then you can do the same thing again. You can go back and then you can use this inside a function, right? Just say copy array, and you can call that, and then you can reset your numbers to store the original numbers again without affecting the original array elements. It's really important part in arrays. This applies to not just Visual Basic but other languages as well. Arrays are always a reference type. Okay, and that is why it also allows you to store a list of data. So it's in one memory address, memory location, but it allows you to store a list of information of data in that same address. Any questions on arrays so far? Okay. And that is also a little bit dangerous, because if you happen to delete the new numbers, all the data, if you wipe it out, then of course, if you don't just copy it, if you do this assignment operator here, then you also delete everything from the original array, and that could be a problem. Okay, so, or you might get a completely different result from what you expect. So we got that. Why don't we take a break again, and we'll come back and we'll do the for each loop to loop through this array and a few more with arrays.